Welcome to the last part of this lesson, and I'm going to explain a very important concept in programming called pass by value and pass by reference. And if you want to ignore all of the other parts of this lesson, it's okay, but please do not ignore this part of the lesson because it's quite important. So let's move on to some practical examples, and I'm also going to illustrate on a whiteboard what the contents of memory is as we step through each statement in the program. I'm going to create a structure first, and then I'm going to create a class, and then I'm going to pass some values around within that structure, and I'm also going to pass some values around within the class, and you'll see that there's quite a big difference with how a structure is represented in RAM and how objects are represented in RAM and how they're handled in a different manner. So let's create a simple structure. I'm calling the structure of type struct, and I'm going to make this structure very, very simple. It's just going to have one property, and when new instances of the structure are created, they're going to initialize num1 with the value of 10. So once the structure is created, I am going to, in line number 15, I'm going to create a new instance of the structure called struct1, and it's going to be of type structure. And at this stage, struct1 will initialize this property of num1 with the value of 10. Right, so let's stop there at line number 15 and go and have a look at this stage of the program, what does RAM look like? Okay. Now we get to my very, very untidy diagram of what RAM looks like, but it's sufficient to explain, this program. Okay. So in my hardware module, I explained that RAM has different parts to it, and there are different places on RAM where you can store information or data. One place you can store information is called the text segment. There's another area called the data segment, and then you also have the heap, and you also have the stack segment. So for this lesson, I'm just going to use two parts of RAM. One's called the data segment on my left and the heap segment on my right hand side. And it's a very simple structure. It's like post boxes. If you look at the data segment on the left, it has addresses 01, 02, 03, 04, and at these addresses you can store data. Okay, these are little boxes you can store data. And the heap is arranged in the same way. You have addresses like 111, 112, 113, 114, and you can also store data in these boxes. But there are two separate areas of RAM, but living on the same chip. Okay, and I'll tell you the difference now, why we need these two separate areas of RAM. I'm sure you may have guessed, whenever data from the structure is stored, it's always stored on the data segment. And whenever data from the object is stored, it's stored on the heap segment on the right hand side. So, we were at line number 15 where we created a new structure called structure1, whose property was initialized to the number 10. So if you look at what the RAM looks like now, there's this structure1, that variable called structure1 num1. If you are to look at RAM, it will be sitting at a certain address, and at that address you'll find the number 10, which is structure1's num1. Okay, so far so good. Right, let's move along to the program. Now I'm on line number 17. I'm saying create a new structure called struct2 and take the contents of struct1, make a copy of it and put that into struct2. So that's where the pass by value comes in. And I said to you, pass by value means make a copy. So what will happen is a new structure will be created, struct 2 with its own number 1, and the contents of struct 1 will be copied into struct 2. Whenever anything's copied, the original remains the same, but a copy is made into the destination. So at this stage, struct 2's num1 will also be 10, and struct 1's num1 will also be 10, because a copy is made. So let's have a look at RAM, how that looks like. Okay. So struct 2's num1, a copy of struct 1's num1 will be made, and struct 2's num1 will now also be 10. So there'll be an identical copy here. So there's 2 copies of 10 now, one living in struct 1's num1 and one living in struct 2's num1, which are 2 separate entities. Okay? We just made a copy of it. So that was the status at line number 17. Now let's look at line number 19. I'm saying take the value of 20 and make that the new value of num1 of structure 2. So I'm altering the num1 value of structure 2 and altering it from original 10 and now making it 20. So let's go back to the memory. So there's struct 2 num1. I'm altering this, making it 20. Now, although a copy of struct 1's num1 was made into S2, struct 2's num1, but when I alter the num1 value of structure 2, that has no bearing, it doesn't alter this value here, because these are 2 separate values. Okay? Now let's verify that that is really the case. Let's examine what struct 1's num1 is and what struct 2's num1 is. Let's go back to the program. Okay, so here I'm printing out struct 1's num1, and you'll see it's 10. And I'm printing out struct 2's num1, and here you see it's 20. That didn't affect the num1 value of struct 1, which is consistent with what we have in memory here. We have a 10 here and we have a 20. So that's how structures handle moving data around. They do it by copying, or we say pass by value. Good, now that you understand pass by value, let's move along to a second concept called pass by reference. And this is where we're going to use the heap on the right hand side. Now let's go back to our program. Let's look at the second part of our program. Here I'm defining a class called SomeClass. And I'm going to make it a very simple class. It's just going to have one property called num1 again, and I'm giving it the initial value of 10. Now that I've created the class, let's create an instance of that class, which is an object. So class 1 is an object of SomeClass, and at this stage, class 1's num1 is going to be initialized with the value of 10. Okay, I'm on line number 32. Now after executing line number 32, let's go and have a look at what memory looks like. Okay, now here I have class 1's num1, or object number 1. Okay. At this memory location 03, the number 10 is not stored. 10 is stored on the heap. Okay. At address number 111. So what is stored on the data segment is not the number 10, but it's the address. Okay. So what I'm saying is that the variable, the property num1 does not store the number 10, but the property num1 stores the address of the number 10, which lives on the heap. So if you're looking for the number 10, you have to go into num1, find the address, which is 111, follow that address, go to 111, and there you would find the number 10. Okay? So after executing line number 32, that's the status of our memory. Let's go to line number 34. Right, line number 34 is interesting. It's saying, take the address of class 1, okay, and place it into the object called class 2. Right. Now it's not saying take the value of 10 and place it into class 2 and make that 10. No, it's saying take the address. That's what we call pass by reference. Take the address that's living in class 1 and make a new class called class 2, or make a new object of a class and call that class 2. And let's have a look at what's going on in RAM. Okay. So I'm going to make a new num1, okay, of this object called C2. And I'm going to give it the same address, okay, as C1's num1. Right. So now what will happen is that C2's num1 will also point to the same address. So now I have C1's num1 pointing to 111, and I have C2's num1 also pointing at 111. Okay. Both, at this stage, both class 1 and class 2, these objects are pointing to the same address, which is address number 111, and at that address is the number 10 that's living there. So both these objects are pointing to the same memory location. Or another way of saying it, both these objects, pointers, are pointing to the same memory location, okay, or referencing the same memory location. Now let's look at line number 36. Take the number of 20, go to class 2's num1, go to that variable or object or property, and there you will find an address. Then go to that address and update that value and make it 20. So go to class 2's num1 and find the address, and at that address you'll find a variable on the heap, and then make that equal to 20. So let's have a look at what that looks like. So you're saying go to class 2's num1, okay, go here, there you will find an address which is 111, then go to that address, which is this address here, okay, and there you would find the data, alter the data and make it 20. Okay, so what has happened now? Because 20 has been changed and both C1 num1 and C2 num2 point to the same address, so if I output C1 num1, since C1 num1 is also pointing to 111 and C2 num1 is also pointing to 111, if I output C1 num1 and I output C2 num1, both should give me the answer of 20 because both of them are pointing at the same address. Okay, let's take a look at it. I say print line class 1.num1, you notice it's 20, and class 2's num1 is also 20, because both of them are pointing at the same address. So in classes, the takeaways here is that whenever we work with classes, the data is stored on the heap and there's only one copy available. And both those variables are pointing to the same single copy. That's called pass by reference, where we pass addresses around. We don't actually pass the data around. But when we get to structures, we make copies of the data. We don't pass addresses around in structures. We actually pass the data. We make copies of the data. I hope you enjoyed that explanation of pass by value and pass by reference. And please have that notion that whenever you work with classes, it's always pass by reference. And when you work with other data types, like enumerations, structures, integers, booleans, dictionaries, arrays, by default, that is pass by value.